session 22. This morning, we're going to hear from Dr. Aaron Geller once again, who will tell us about particle visualizations, working in 3D, and tips and secrets, and probably also some things you should not do when rendering in more than 2D. So, Aaron.
Yeah, thanks, Adam. So good to see you all again. Remember yesterday when I said you probably should not do things in 3D or try your best not to do things and instead project into 2D, or sorry, not really project, but use two-dimensional representations of multi-dimensional space. Well, today we're going to do the opposite. We're actually going to do things in 3 dimensions, but in this case, it will be on a flat screen or on the screen of your laptop. Today is going to be more like a practical tutorial, whereas yesterday was kind of like pie in the sky ideas and playing around. Today we have some like real hands-on stuff that I'm hoping we can all do together. It's going to start with a kind of a lecture, but with exercises that you can play along with. And then in the end, we have, of course, the usual exercise where you will play along on your own. If you want to really follow along and run some of the stuff that I'm running here during this presentation, I recommend that if you haven't done so already, you go to my GitHub repo. The link is in the Slack, but I can put it back there actually, just so it's right in your right there. That should hopefully take you there. I'd recommend that you download this repo or clone this repo, because I assume you all know how to do that, but if not, it's this green code button. That's where you go and gives you either the command to clone it or download the zip. We are going to be working in web-based particle viz, and I have 3 different examples that hopefully we'll have time to get through. The first 2 that with the name simple are the ones that will be mostly during this first hour, and then the exercises we'll be working in Firefly, and that's something that I introduced to you yesterday, but I will talk about more today. All right, let me put this back up. All right, so before we got started, I did like an informal poll of how many of you have used created websites, actually coded in HTML, JavaScript, CSS, and some of you did, and that's fabulous. I am going to walk you through some JavaScript code today, just so that you kind of get a flavor for how this is done. I do not expect you to actually like understand everything I'm showing, but it's like giving you tools that you can look at later if you're interested. And then we'll work with Firefly, which you'll just be able to do through Python, though it is written in JavaScript, which is why I want you to kind of get that background to get started. Another motivation is, so I know that we're all astronomers here, and we all have aspirations to maybe, go on in academia, but maybe you also have aspirations to go on as a data scientist or as a software developer. And one of the most sought after skills is JavaScript. And personally, that is like my favorite language. Love JavaScript. JavaScript and Python are kind of my 2 favorites, but JavaScript is just cool because you can write stuff for the web. It's like built to be interactive. It's very, I don't know, to me, it's fun. All right, so why are we talking about interactive particle or interactive visualizations in general on the web? All right, so motivation for interactivity. You have the ability to interrogate your data in real time. So like, you have a question, what happens if I filter the data in this way? What will that look like? What happens if I rotate the data? What happens if I color it this way? If you can do that all interactively, it can save you a lot of time. The alternative is like, write Python script, Shift Enter, whatever in your Jupyter notebook, see image or maybe render movie, don't like it, change setting, change code, do again, repeat thousands of times or whatever until you get exactly what you want. You can also, I would argue, you build intuition about your data a lot better when you have this interactivity. There is something about being able to rotate it around, get to see the three-dimensional structure of your data that you don't get from just doing this in like 2D projections. I think it also enables serendipitous discovery a lot more than just a static image or any sequence of static images. You know, you might have the ability to kind of scrub through or move a slider through some regions of your data that, you know, gives you kind of like very fine tuning on what exactly region of the data you're looking at, which would again be very time consuming to try to create, you know, like 100 different static figures. And this can be very engaging for the public. So if you are thinking of, you know, doing any type of public outreach, or for instance, working in a museum and creating exhibits, people love to be able to manipulate data on their own. Okay, and all of these, you know, building intuition, enabling serendipitous discovery. I think that can be very powerful for, you know, the public, you know, whatever, the person who comes who is not a scientist, but gets the ability to act like a scientist while they're looking at your data or interacting with your data. Okay, so why do we use the web for this? One reason is it works on any, in principle, works on any operating system. So, you know, I use Windows, many of you use Mac, lots of people use Linux. There are definitely software that work on one and not the other, and so forth. But when you're building something for the web, as long as it works in Chrome, it's going to work in Chrome on all of your operating systems, for instance. Something, depending on how you build it, it can be very easy to share online. So for instance, if you have a website, everyone can just look at it, as opposed to needing to install your software and so forth. Of course, we are going to install Firefly. There are many existing libraries in JavaScript that will help you create all these things. You know, just like Python has all of its libraries, you know, NumPy, Pandas to do all these things, JavaScript has a ton of libraries as well. Whole different ecosystem. And it's, you know, more or less endlessly customizable. So if you dream it, you can do it. All right. We are going to use a library, or Firefly uses a library called 3.js. And this is kind of like the go-to library for something called WebGL. I know I asked if anyone's used WebGL. How many of you have heard of the term WebGL? Okay, how many of you have heard of the term OpenGL? Okay, so there's actually kind of not a total overlap of the two. Those are very similar. So OpenGL is like, how do I create three-dimensional graphics on my desktop? WebGL is like, how do I do that same thing on the web? Okay, so the browser would render your 3D graphics using your, you know, hardware on your computer, running the code that you write for, you know, in JavaScript. And there are, you know, a few different ways you can do that. And the easiest one is the library 3.js. And you may enjoy going to their website. It's like any, you know, website that has the gallery, but in this case, it's like really wild things that you can do, you know, avatars walking around and, you know, I don't know. They even have something that shows a cloth blowing in the wind, you know, it's just like stuff that you might think of for games, but you can also use this, of course, as we will do, for data. So like I said, I'm going to spend a little bit of time, and I hope you'll indulge me, going through kind of the nuts and bolts of how you would create an app on the web. And we are going to look at a simple one, and then we are going to use Firefly, which is far more complex, and you do not have to understand the code, but we will learn how to use it. But you will at least understand kind of the principles behind it. Okay, so there's a few different kind of standard components for a 3.js scene. And I'm going to kind of walk you through in words, and then we're going to look at code, and then we're going to look at more complicated code. So the first is actually the scene. So that's basically an object, a JavaScript object that's going to create or contain all the different things that you want to have in there. So we're going to look at one scene that has a cube, and then we're going to look at one scene that has a bunch of points. There's a renderer. So this is the object that basically takes the numerical input, talks to your graphics card and puts that in the scene. Draws it on your canvas that's on your browser. There's a camera, so that's basically you moving around. How are you going to view this object? From what angle? How far away? And then controls, which are how do you move that camera? So there are various ways that you could imagine moving that. You know, is it centered always on an object and you're just orbiting around it? Or are you free flying around space, for instance? These are all things that you need to think about. And, you know, if you were creating any movie, just not in JavaScript, but you were creating some Python movie, you would, in a sense, be thinking about all this as well. You know, how am I going to move the camera around to make this interesting? And so forth. Okay, so I'm going to walk you through what I would usually do. And again, it's okay if this is like something that you are not ready to fully understand today, but it could be helpful for you in the future. And please feel free to ask me questions. So I would typically, if we're talking about some type of data analysis, data visualization, I would read in a data file. And there's a great utility through this library, d3.js, to read in a data file. D3 is also a very powerful library. So like the that LIGO mass plot, that two-dimensional LIGO mass plot that I showed you the other day, that was basically created mostly with D3. D3 is like the two-dimensional equivalent of 3.js. Don't ask me, that's data-driven something, but you know, it's not actually 3D. It can do, but it's not meant for that. Okay, so the first thing I would do is read in some data, then I would initialize all those elements. If I needed some type of graphical user interface, so you know, something with drop-down menus or sliders, I might use one that's already built. And here's a great example, and I'll show you that in action in a little bit. Right, so I don't actually have to write my own script or, you know, so this would be like pandas, for instance. I don't have to write my own script to create a user interface. Someone's done that, though I can, and Firefly does have its own. Then I would draw each item, add them to the scene. And there's some vocabulary here. So you have what's called a mesh. You ever hear terminology like this? A mesh is like an object that goes into the scene. And that consists of two things: geometry, so the actual XYZ positions of all the vertices, and the material, like what is kind of spread over all those vertices to give it color, for instance. Okay, and then you have some animation loop. So basically what this is doing is every time the browser is ready to render an image at whatever frame rate, you know, your laptop can handle, it's going to check the code to see what it needs to render. And it's going to go through all the processes of like looking where the camera is, asking the renderer to talk to the GPU, and produce that image at a frame rate of, you know, 60 frames per second or whatever. So it looks like it's a video. Yeah, and this just runs endlessly. And that's basically how it makes it look like it's an interactive thing, right? It's just many frames rendered very rapidly. All right, so let's talk about a little bit more of the vocabulary here. Right, I said a mesh object has two components. One is a geometry, and one is material. And like I said, geometries define all the vertices. And basically, you're imagining drawing three-dimensional shapes. If you think of a, you know, something like a person, for instance. Imagine dividing that person up into triangles. And that's basically what you're doing here to create this mesh. It's like a wireframe. Okay. And a lot of these already exist in 3.js. So like simple ones, you can do a sphere, you can do a box through 3.js. You don't have to actually like read in a file that has all the geometry points, all the vertices, but you can. You can also construct 2D shapes and so forth. Okay, and then right, and making sure there's no echo. Okay, sorry about all of that. We got the blue screen. Never like to see that on Windows computer. So hopefully we'll make it through the rest of it. Okay, so we had just talked about geometries. I had actually clicked to materials and then we died, but now you can see. Right, so I was telling you that geometry are the vertices, material is what you basically put over those vertices to fill it in and give it color, texture. Again, 3JS has many different kinds of materials. The one that we will probably be using is something called points material. And that is like you are actually defining locations in space where you are going to have little icons, little circles, points. Okay, that's what we're talking about today. There's also, you have lots of customization. So you can write code that talks directly to the GPU. These are called shaders. And that can tell you all types of detail of how you want to process the information coming to the GPU to create a material, or to perhaps compute an n-body model and move the geometry around. So like I showed you that example of the star cluster that I created in Unity that both on the GPU calculated the n-body dynamics and visualized it. That was done within a shader. So that's a different language we're not going to talk about today, but directly talking to the GPU, right? So you might have heard of like CUDA, right? So that's a way that you can do this. This is a similar concept where you're writing code that is run directly on the GPU. So it's actually a really powerful type of calculations that you can do in this type of framework. Oh, and then there's also another bit of jargon. It's called a texture. So these are like little images that you can, or larger images, but anyway, images that you can, send to the GPU as like a PNG, for instance, that then gets formatted through 3JS to be read in as pixels that you can then map to different points on your scene. So like, for instance, if you wanted to have a bunch of points, and each one of those points is like a picture of your face, that face would be a texture. And it would just be, you'd have one texture and it could be remapped all around to every point. All right. Fingers crossed. Okay, we got to the next slide. Okay. So we're going to look at a little bit of code. I have it here with some helpful kind of words, and then I'm going to actually hopefully pull it up in VS Code, and we're going to run it. And this, at that point, you could actually run that together. So this with me. So this is included on the GitHub repo under the subdirectory simple cube example. And I'm going to talk through the code. There's two pieces. Okay, there's one that is written in HTML, and there's one that's written in JavaScript. So HTML is something that you are probably more familiar with, and this is the language that you use to create any website. So basically tells you the layout of, I want my name here. I want a box here that has a purple background, and it should say, my title or whatever. So normally you might have a very large HTML document that has all the text of your website. For our purposes here, it's going to be actually a very small HTML document that just, basically sets up a style of, we want a canvas and a body that fills the entire page. We're going to import the 3JS library. And then the actual body of HTML, which is stuff that you would see, the user would see, is just loading in a JavaScript. That's the entire extent of our HTML code. This is like the simplest, I'm giving you like the simplest setup for a 3JS scene. And then we have our JavaScript. And this is kind of the simplest setup. This is one of the examples that they give on the 3JS website. And I'll walk you through this code. And this is like, okay, if you absolutely do not like or do not understand the JavaScript. Because I think the purpose of this whole thing is to teach you more Python than JavaScript. But as I said, JavaScript is one of the most sought after and, in my opinion, fun languages. So this is an opportunity, if you want, to kind of dig in a little bit and get to know a little bit of JavaScript. You might notice that it looks quite similar to Python. They're both object-oriented languages. They they have a lot of similarities in like syntax and the different things you can do. So like, for instance, I'm importing the 3.js library, just like you would import some Python library. I'm defining some variables. So I have a scene, and that is, so this is a little different. It's not something you see in Python, but we're calling it a new 3.scene. That's an object that came from this library. I'm setting up a camera with some arguments that define basically the size and the distance that the camera can see, and giving a position. So, right, this is an object. The camera is an object. Camera dot position, which is also an object that has XYZ, dot Z equals 5. Okay. So it's not too dissimilar from Python in that sense. Okay, I'm setting up the renderer, like I mentioned. So this is what basically talks to the graphics card and eventually creates the scene for you to view. Okay. I'm creating it. It's a WebGL renderer. I'm giving it the size. So this is the actual size of the window. So, you know, whatever you started your browser window at, that's the size of the renderer. And then I am actually using some built-in objects that come from the HTML. So this is actually the body of the HTML. I'm appending something that's going to actually be visible to the user, which is the renderer DOM element. Okay. Creating my geometry, just a box. My material, it's just green. So this is like RGB. Putting that together into a mesh. Remember the like kind of jargon that I had before? A mesh consists of a geometry and material. I'm adding that to the scene. Right, scene was defined above. Scene.add, I'm adding the cube. And then I have my animation loop. So this is a function that is just going to go endlessly. Request animation frame is like browser, whenever you're ready for your next frame, do this. So, okay, so just keep going. Rotate the cube and render it. And do that endlessly. Oh, and then call the function so it actually runs. Any questions about kind of the layout there? Yeah.
So, sorry, how would you stop?
Yeah.
Closing?
Control C. Close the browser. Stop the server. Yeah. No, it never stops in this sense. It goes on forever. Yeah, great. That's a great intuition of what the code would do. Other questions? I'm going to hop out of this and take a look at the actual code in VS Code. If my computer allows. All right, let's see. Okay, I have the same code here in VS Code. This is from my simple cube example. I've got index. I have main. It's exactly what we just looked at. I am going to pull up a terminal here and go to that website. So if you have this on your computer or later you want to follow along, these are the steps that you would take. I think I have this on the GitHub as well. All right, let's see where. I'm going to go to web-based particle, simple cube. All right, so I'm in the same directory that I'm looking at with these files. And I'm going to use Python to start a server. http.server. I don't know if you can see that. Python -m http.server. So Python has its own web server. That's how you would allow these to run locally on your computer. So like if these lived on someone else's web server, like if they lived on GitHub and you create a GitHub page, GitHub would have its own web server and it would serve it to everybody in the world. But if you want to kind of preview this stuff locally, you can do this with a Python server. I'm gonna do that. And it makes it available on this URL. So this is like localhost, your computer, 0.0.0 at port 8000. I am going to open this in the browser. And there we go. It's a rotating cube. Just like we suspected it would be. I want to show you just a couple other things when you're looking at a browser. So for those of you that are like very interested in this type of web development, the browser gives you a lot of different tools. And one of the things that you will find the most useful, hopefully, is going to this More Tools and Developer Tools. This gives you a whole bunch, I'm not going to go through everything in here, but this gives you a whole bunch of different utilities. So one of which is this console here. This is where you would find different error messages, or if you had print statements from your code, which in JavaScript is console.log, you would see it in here. So right, if you ever need to debug your code in JavaScript, you need some way to do that. And that's where this is, the console, the developer tools. But yeah, so we have created this. There are no controls, like I cannot freely rotate this myself, but this is my first simple example of a 3JSM. Okay, so I'm closing the browser. I'm going to Control C down here, and it is no longer infinitely looping and using my GPU. How are we doing so far? Good. All right. Okay. Oh, here we go. So here was the directions that I just shared. All right, cd to your directory, python -m http.server, point your browser to that URL, and that will hopefully give you the spinning cube. Okay, now we're going to go with one more demo before we get to Firefly, because I want to give you something that's a little bit more realistic, something that you might actually imagine using. And we'll talk about some of the limitations and the reason why I developed Firefly. Alex Gurvich and I developed Firefly. This is going to be a very simple, similar thing. I'm going to show you the code on VS Code. It is, fair warning, it is longer. There are more files. It's more complex. But I'll walk you through it. I'm going to do it fast because we don't have a ton of time. I'm happy to answer questions, but it is okay if you don't understand it now and you come back to it later, or not. Okay. But we're going to do a very simple, similar thing. If you want to explore it on your own, we're going to go cd to the directory where all those files live on your computer, python -m http.server, and go to that URL. I'm going to do that first so you can see what it is, and then we're going to look at the code. Oh, let's go to VS Code. I'm going to close these. We will take a look at simple particle example. So I have this formatted. I have the directory structure is a little bit different. So I have my index.html, and then I have all of my other things in this src directory. This is just a personal preference. It's just how I like to organize my code when I'm doing JavaScript. And I'll show you the code in just a second. But let's go back here, simple particle example. So I want to be where I have my index.html, python -m http.server. And let's refresh. Okay. So what we're looking at here is points in space. Oh, let me turn this on. Sometimes it's easier to do this with the mouse. Points in space from a very outdated supernova catalog. But it's still fun, right? So each of these are detected supernovae over some time period. And I actually forget what they're color coded by, but we'll look at it in the code. I have a graphical user interface, a GUI up here with various things that are going to, I can drag this to make the things bigger or smaller. And, various other things. So for instance, you have the option of, as I zoom in, should the points become bigger? And as I zoom out, they become smaller. Or should they always be the same size regardless of where the zoom level is? But you can imagine all types of different things to put in this GUI, and Firefly does have all types of different things in here. And of course, different controls for the color map, right? So all this stuff happens in real time, which is fun, right? And this goes back to what I was saying. Obviously, these are, very simple examples, but you can see already how nice it is to be able to do that real time. Like, I don't know what I should set for my color map min and max. Well, I could make a ton of different images in Python, or I have this interactive here and I can say, oh, that seems about right. and so forth. Okay, so like I said, this is probably a similar type of use case as maybe you would envision using for your own data analysis. You got a bunch of points in space and you want to render them. Let's take a look at the code. All right, let's take a look at the index.html. It's very similar, but a little bit more stuff coming in here. So as before, I am importing 3JS. This lives online. Okay, I'm importing from this repository. I am importing D3. This is another JavaScript library that I'm going to use here only to read in the data file of the supernova. And then I'm also importing this dat.gui. I mentioned this earlier, this is what allows for this over here, the controls. And it's a great library. And then in the body, I'm importing my own scripts. So I wrote all these scripts. You can, the other one, the cube example, I just had one script. And here I chose to break them up. This is kind of, it is, your choice how you want to create your code. This goes for Python and JavaScript. Best practice is like, for instance, if you're creating functions, which you should consider creating reusable functions, period. But every function should have like a minimum task. This is like best practice for code development, one task per function. So you might have many functions. And I choose to break up my code into like one task per file, one overall task per file. Each of those might have multiple functions. All right, so I'm loading in. We'll look at the JavaScript code. Oh, and by the way, I have two different directories as well. One with data. This has this CSV file with the supernova data. And a texture, like I said, this could be your face. All those points could be your face, but in this case, it's just a circle. Okay. But the real interesting stuff is going to be in the JavaScript. So let's take a look. We've got a few different scripts. One, draw scene, does as you might expect. It does everything necessary for drawing the scene. One is GUI, does everything necessary for creating the GUI. One is init. We're going to look at that one first. That's basically to initialize everything. And params, I like to have a kind of global object that contains all of the variables that I want to be accessible to all of my other files. This is not totally necessary, but this is just the way that I choose to code in JavaScript. So let's just quickly take a look through. And like I said, the code is more complex, obviously, than the other one, but it's going to have similar elements. And so I'm going to try to point out those similar elements quickly enough that we can get to Firefly. All right, I'm going to scroll, give you a global overview, and then I'll go in some detail. I have a few things in here. I have an initialize function that does the types of things that we had before. It gives you the renderer, creates the scene, the camera, and in this case, I actually have controls. So I'm going to be, as you saw, I can use the mouse to move things around. I have my animation loop. I have another function that you didn't see before that is basically starting everything up. I'm going to call all the various functions that I need to make everything work, including animate. And then all of this stuff, these are just functions. They wouldn't run unless they were called. And at the bottom, this is living on its own. This happens right when the page loads. So I'm using D3, the D3 library, to read in my data file. After it's read in, this then function, after it's read in, I basically, a console log, I can show you that. So this is like the print statement. I'm printing the data to the console just so I can see that it works. And I'm running my WebGL start, which was this function above that initializes everything and starts the animation. And if there was some error, I'm going to actually write that error to the console so I can see what's happening. So when the browser loads, this fires, comes up to WebGL start, goes to init, which sets up all those 3JS objects that we talked about, creates the user interface, that's in GUI.js, I'll show you that in a second, draws everything, That's in the draw scene. I'll show you that as well. And then goes to the animate loop, which is right here. Very similar to what we looked at for the cube, except in here, there's no like rotate cube. It's just update based on the controls. So if you had moved things around, it's going to update the camera as needed and render the scene. Okay, so the next thing in here was create UI. That's in the GUI. So this is using that JavaScript library to create this. I'll show you. To create this GUI on the side here. And it's really, I mean, this is a great library. It's so simple. I mean, this is a really nice, functional, though not beautiful GUI, but it's super simple. I create the GUI object and I add different elements. So I add size, you can see size, alpha test, and so forth. And every time that it changes, every time the size changes or any of these things change, I redraw the scene. So in that draw scene, it's like create all these points with all these sizes with this color map. So every time that I am sliding that slider, it's basically deleting the scene and redrawing it. It's almost like amazing that the browser can do this so fast that you don't realize that that's what's happening, right? So like every time I slide this, the scene has been erased and redrawn. And you don't know that. I mean, it's just so fast. Okay, we're back in init. The next thing was draw scene. So I'm going into my draw scene code, which has a function called draw scene. That's what's being called. And this has the kind of similar things that you would expect. It's creating I'm scrolling down. It's creating a geometry. It's creating a material here and creating the mesh and adding it to the scene. There's more code in here because I'm actually like using the data that I read in to create my geometry. So it's a little bit more complicated than just using a 3JS function, create a cube, but not overly complicated. I'm also setting up my color map. So I have a color as well as a position that I'm sending to the geometry. And some of this stuff are set by, actually a lot of these are set by my global params object. And so let's take a look at that. Like I said, this is a personal coding preference. In many of my JavaScript codes, I have some global object that has a whole bunch of variables that I want to set up, move around. And, you can imagine this is like, you might have in your code some input file. Maybe it's a YAML file or, just a CSV file or something that you read in that sets your parameters that you can easily edit. This is my version of that. So this could be converted to some type of other format. But for instance, this is where I'm setting the texture that I want everything to be. This is where I'm setting the color map. It's reds, but I could have used something different. I could have used Viridis, for instance. These are my initial minimum and maximum for the color map. And so forth. Oops. All of this goes together, of course, to create that interactive here. And I encourage you to just kind of, play around with this on your own. And, if you're really interested, you can try changing some of these. Like, for instance, what would happen if you instead used this, interpolate Viridis instead of interpolate reds? By the way, this is a comment in JavaScript, // That's a JavaScript comment. Or what would happen if you created your own texture and put that into my textures thing and use that instead of circle, for instance? That's not actually our exercise, but if you feel ambitious later on and want to explore, you are welcome to do that, and I can help you through. All right, let me just see where we are here. Okay. So I know I went through that fast, but I wanted to save us time so that we can get to Firefly before the break. Any questions about that just in general or specifics, I guess? Yeah.
How easy is it to import data, say like a Django or SQL database versus a static CSV?
Less easy, I would say. Yeah, importing data is actually, I found to be a bit of a challenge. And as I'll also explain, I think, in Firefly, one of the motivations for producing Firefly was that once you get to like a really, really big CSV file, like if you wanted to show 1,000,000 points, the browser can do that. But this like simple D3 read CSV kind of dies when you get to that many points. So it is kind of limited, but you can certainly do it. It just, you have to create some reader, and there's probably a library for that. Yeah. In Firefly, we have a few different kinds of readers. We don't have anything for SQL though.
You've been mentioning lots of different libraries that you can just import. Is that just like a big repository somewhere you can be like, I want this thing, and they're like, oh, you have all of these different options.
Yeah. So I mean, part of it is like, it's a similar concept to, Conda, right? It has, the JavaScript equivalent is Node, an NPM. Node pack, I think it's a Node package manager. So it's very similar to Conda. So you would like npm install package on your computer. I have sidestepped that whole procedure here by just linking to where they live online. So there's various ways that you can do this. But if you wanted to do it through Conda and you wanted to have some place to search, it would be NODE, Node. But part of it is just like kind of knowing what is a good package for this use case. And that's like, I don't know. I mean, that's like a Google or talking with people who know. So like 3JS is the package for this type of WebGL thing. D3 is like the package for these type of 2D, like the best, I should say, the best. But there are other ones out there that you could potentially use. And some of it is just, learning and talking with people. I don't know. I mean, like, how did you know that pandas was the right thing to use in Python? Well, it's probably like something through this that they told you, like, use pandas. Don't just use, write your own function to read in a CSV file.
There's like some Reddit out there about people talking about their favorite movies.
Yeah.
Okay, cool.
Yeah. So like, I'm trying to think of how I learned about this dat.gui. I definitely like started by writing my own GUI code. And then I think I saw someone had this dat.gui at like some conference, and I was like, wow, that's much better. And simpler. And so, yeah, so it's that type of thing. Yeah.
What was the file that you like called those other three .js's in? I got lost.
Oh, no problem. Okay, so there's a few. So starts with index.html. This is a name, I don't think I mentioned this. You might be asking, why is he calling all these things index.html? This is like what the browser expects. So if you point your browser to like www.aarongeller's homepage / whatever, it is going to look for Aaron Geller's homepage / index.html. That's what the browser looks for. And so it is good to name your like homepage index.html. Otherwise, you have to specify the actual file. So like if it was named mypage.html, then whenever I share a link to someone, it's like Aaron Geller's homepage / mypage.html. And then, they have to go to that. So yeah, so this is where, this is like the first thing the browser sees is index.html. And that's where it loads in my JavaScript modules, my JavaScript files, where all the heavy lifting is done. Other questions? Cool. So let's talk a moment about Firefly. Okay, so Firefly went through a lot of iterations. And as I think I explained yesterday, the motivation behind this was initially the Fire team who creates galaxy simulations that have, you know, millions and potentially billions of particles. They wanted a way to visualize their data in real time, rotate it around, filter, fly around it, to enable scientific discovery. It's, you know, it's a very complex data set, very hard to think of like, here's a Python script to write to isolate this particular thing that I want to study, but much easier if you can do this interactively. And it started out with some other code architecture written in Python and some kind of proprietary software. And then Alex Gervich and I, actually, he was a student of mine in a kind of 2-week intensive course that I used to teach, that also introduced WebGL. Alex was a grad student here. He's currently working at NASA, in the space visualization group. And he was really interested, and I like challenged him. I was like, and so he was part of the FIRE collaboration. I was like, let's simplify this. Let's see if we can do this on the web. And he wrote a kind of prototype, and then we went and built it out into what it is today. And it started out as kind of like that supernova cloud that I just showed you, right? That kind of quote unquote simple particle example. But we quickly realized that the size of data from the FIRE simulations was way too much to do in that kind of simple way of read in one big file and render it that way. So we had to figure out different ways to read in multiple files, different ways to ingest this FIRE data, which isn't actually a CSV. And we ended up splitting this out into having a Python kind of data processor. So ingest data via Python, create the data that would be necessary for Firefly, which is written in JavaScript, to run. And in the version I'm going to show you, we can do this all within a Jupyter notebook. So you can basically send data to Firefly. Firefly, like I said, is written in JavaScript. It lives in the browser, but you can look at that browser in a Jupyter notebook, and we'll do that. Just another bit of kind of terminology, though not super important to you. In addition to the Python the Python kind of data processor, Firefly also pairs together the front end JavaScript. Basically what we were looking at. We were looking at front end stuff. This is stuff that lives on the browser that people see. And a Python backend, which is something that lives on the server, which in your case is still going to be your computer. But it basically allows something to happen in the browser, come back to Python so you can do some type of more complex data analysis in Python, send that back to the browser. And so there's some communication between JavaScript and Python, and we're using a tool called Flask. You may have mentioned Django is another kind of back end that is very popular in Python. Okay, so that would be how you would read in the SQL file and then send it. Okay. All right. So this adds another layer of complexity, and we are not going to get into how that code looks, but I'd be happy to talk about it. It's actually, I mean, I personally had a lot of fun kind of figuring this out. Like I said, built primarily by Alex and myself, and we did a lot of this pre-2021. I was looking back at the commits on our GitHub repo. I would still consider that. So basically, Alex and I had thought of this as like our kind of playground for how can we do this kind of interesting thing. So it has been built out over the years to have many different features. So you could look at it in 3D through Google Cardboard. You can, send data directly to it from Python. You can, you can select data. I'll show you how to do that and download that back to have that then available to you in Python. Many other things. One way that we tried to solve this issue of how do you visualize billions of data is to build in what's called an octree. So we kind of partition the data and then only load in the stuff that's nearby to the camera rather than trying to render all billions of stars. That's how we get around the issue with Gaia and being able to actually fly through Gaia data. So there's a lot of features that we kind of built in. And including like one that we did where we like had a use case for what if you wanted to render it everything on like your HPC and then only stream across images to your laptop, which may be low powered, right? So that you're able to interact with it, but it's actually being rendered somewhere else. What else do we build in? Oh, we had a version that was like, we're going to use this at the Adler. So, you know, we have some controls. We have a viewer that actually shows the beautiful data. So we separated those out so you could have the controls without, sorry, you could have the viewer without the controls, have the controls available on an iPad and kind of like use the iPad to manipulate the screen. And as you might imagine, with building all that stuff in, the code got quite large. And as Alex and I look back on it, we think, boy, we could have done some of this better. You know, we could have used, like, for instance, React, or we could have used some other framework to make these things work better. But like I said, you know, it was kind of our learning tools. And if any of you are like super interested in this, you could contribute to Firefly by building different modules or refactoring the code, for instance, if you wanted, in various ways with Alex and my help. All right, I think I showed, let me just double check. So I did show this yesterday. So yeah, so we don't have to show this again. But I do want to show Firefly in action. This is a movie in case it didn't work, but I'm going to show you it actually in real time. And we are going to, I'm going to show you this quickly. We're going to break, and then I'm going to have you all do this together with me for the project as we build into the project. Well, let me just show you give you a preview of where we're going here. In the remaining 2 minutes. If it works. All right, so we're going to go into, I'm going to close all these. We are going to go into Firefly example. And we're going to look at minimal Firefly example. I posted in Slack yesterday a command to create your Firefly environment in Conda. And if you haven't done that already, this would be a great thing to do during the break or at the start of our next session. But I am in that environment right now. I call it Firefly-WSL because I'm on Windows Subsystem for Linux. That's my naming convention. Anyway, we are going to create some data, some random data, just so you can see. Random sphere and a random cube using NumPy, just points sampled randomly on a sphere and a cube. Okay. So imagine that this was your own data that you read it. We're going to use this Python data processor that Alex and I wrote together, mainly Alex. Okay. Creating 2 particle groups, one for the sphere, one for the cube. And I have links here to all of our documentation, so you can see more. All right. Gives you some helpful feedback. Okay, we're adding these particle groups to what's called the reader. That will eventually get sent to Firefly. So this is basically, we've created some data in Python, in NumPy, and now we've formatted it in a format that's suitable for Firefly. Now I'm going to load in Firefly, and I'm going to run Firefly on my computer. So this is like the equivalent of Python -m http.server. But instead of port 8000, I'm choosing port 5500. I am starting Firefly, spawn Firefly server. In this case, I'm not going to load in the browser because I'm going to put it in here. And I'm going to put Firefly into my Jupyter notebook. So if you had data already where Firefly wants to find it, it would load that data immediately and you would see it. In principle, you could click here and load in your data by looking at the Finder, but we're going to send data to it. All right, we have send data to Flask as a function that comes from the myReader object coming from Alex's Python data processor. So I have sent that data to Flask. I'm going to scroll back up here. And we have our data. We have all these points. We have, I'll show you this in a moment, but this is our GUI. We have a cube, which I just turned off. We have a sphere of data and a cube of data. And you have, and as I'll show you when we get back, you have a lot of different options for filtering and all these things, and I'll show you that after the break. All right. Any questions before we take a break? Yeah.
Does it render every individual point at once, or is there a way to render like why is this faster than 3.js for rendering millions of points?
It is actually using 3.js.
Okay.
And so part of what I was, so in this case, it's very similar to the supernova example. But if you get to millions of points, there's a different way that you would need to like read in the data, ingest it in, but it's still rendering using a very similar thing. If you wanted to enable the octree that I kind of alluded at, which we're not doing here, then it would do this kind of progressive rendering scenario. But right now it's very similar to the supernova example, except you have the Python ability to send the data to it and eventually grab data from it. Other questions? Yeah.
Just a point about the install instructions.
Yeah.
There's a bit of a conflict because you're doing pip install, not conda install.
Yeah. Yes. So thank you for bringing it up. So the so typically you want to, in the ideal world, you want to install everything through Conda because Conda has vetted all the packages and made sure that there's no conflicts. That's not always possible. So pip has like everything in the world that you can install in Python simply. Conda has a subset of those. So you'll often get into a scenario where you need to use pip to install something. And so like Firefly is not on Conda. Firefly is only on pip. When you get into a scenario like that, the recommendation is do all of your Conda stuff first, pip last, and you're done. Don't do anything after that. And if you do something after that, it's only pip. And it should work okay. I mean, you can read about it online. People will give that same kind of advice. I mean, it's not ideal, but this should work okay. I mean, another option is that you just create your environment in Conda and then install absolutely everything with pip. And that's more or less what we've done. When you do pip install Firefly, it's going to put in NumPy and all that stuff. Other questions? Okay, let's take a break. When do we come back?